Hello. Today I'll be discussing the security of Google Maps platform and how we help businesses with their compliance efforts. Quick legal disclaimer, nothing in this presentation modifies or amends Google Maps platform terms of service or our privacy policy. Welcome. My name is James Snow. I'm the head of customer trust for the Google Maps platform. And with that, let's just jump right into it. We're going to be talking about security from device all the way to data center. We'll be providing you with an overview of the Google Maps platform security, privacy, and compliance capabilities. We'll be talking about physical security. We'll be talking about data privacy and different controls that you can implement to meet policy, regulatory, or business objectives. After the webinar, you'll have a better understanding of the practices, processes, and certifications that enable Google Maps platform to operate securely. So let's start with security fundamentals. Many users use the term, or customers will use the term security as a catch-all for three distinct concepts. These concepts are physical security or data protection, data privacy, and regulatory compliance. Let's talk about those three different concepts, and then we're going to dive into each one individually. So the first concept area will be physical security and data protection. Physical security and data protection includes a wide range of controls, which can include people, processes, and technology. An example of people would be members of Google's threat analysis group or security guards at our data centers. An example of a process would be Google's process of onboarding and tracking hard drives within our data center, everything from acquisition, usage, and destruction. And an example of technology could be encryption. So using encryption to protect data in transit and at rest. If we move on to the second area, privacy. This is privacy or data usage. Customers want to understand what data Google's collecting and what the data is being used for and how long it's being stored. We'll be talking about this in detail. Last but not least is the area of legal and regulatory compliance. Many customers work with regulated data and want to understand how Google can help support them in meeting these regulatory obligations. So let's start with a deep dive on data protection. Google takes a defense in depth approach to physical security and just focusing on physical security. Examples of these could be controls like biometric identification, cameras, video analytics, vehicle barriers, even laser-based intrusion detection systems. For example, if we're going to start on the outside of a data center and work our way in and talk about those different layers of security, we could start at the perimeter. So this is a picture of one of our data centers in the Netherlands. This is one of the many data centers that we use to provide the Google Maps platform services. Looking at the picture in this perimeter, we can see several different security features. We can see that we have anti-scale fencing. We can see the cameras related to surveillance. We can see the personnel in the guard shack at the gate. And of course, we can talk about these anti-crash barriers, which are designed to withstand the weight of a fully loaded truck trying to run into one of our data centers. Access to Google data centers is highly restricted. We don't do public tours, and less than 1% of Googlers ever enter one. If we move from the outside a little closer inside the data center, as we move closer to the data center floor, we can talk about additional controls that Google puts in place. So here, in the security corridor leading to the data center floor, you can see additional controls that Google's put in place. They have things like metal detectors, again, personal security guards, and a one-way bidirectional security gate to access the data center floor itself. Moving into the data center floor, Google also has different security innovations and controls. Google designs and manufactures the servers that are used to provide Google services. These Google servers run a custom operating system. This is a hardened version of Linux. An example of our custom hardware could also be our Titan microcontroller. In the picture, it's the little chip in the red circle on the network interface card. The Titan microcontroller allows us to establish a cryptographic root of trust on the server. A little more about that. So what is a cryptographic root of trust? So basically, whenever a Google server boots initially, we're going to be checking the cryptographic signature associated with everything from the BIOS to the bootloader to the kernel to the operating system itself. If any part of this boot process does not match what we're expecting, that server is not allowed to boot and it cannot process any data. All of this happens as a preliminary step before that server can store or process any information. Now, moving away, the next question I typically get when I'm talking about data centers and Google Maps platform is customers want to understand where Google Maps platform stores and processes their data. The answer is very straightforward. Google owns and operates a global network of data centers, but the Google Maps platform only uses a subset of these data centers to provide our services. So you may find other resources on the web that talk about all of Google's data centers, or there may be data centers specific to Google Cloud. Google Maps platform is different. We have data centers that operate in the United States, Chile, in the EU, we have Finland, the Netherlands, Belgium, and in APAC, we use the data centers in Singapore and Taiwan. Our infrastructure doesn't rely on a single technology or data center to provide it. Rather, we provide security through progressive layers that deliver true defense in depth. Our hardware is controlled, built, and hardened. Any application that runs on our infrastructure is deployed securely. We do not assume any trust between our services, and the use of multiple mechanisms to establish and maintain trust across our infrastructure was designed to be multi-tenant from the start. So when customers ask which data center is running my particular service, the answer is all of them. And we're going to talk about, again, why we do this. This is done with security and high availability in mind. This allows us to absorb very large distributed denial of services attacks. This allows us to provide our operations and detect threats 24/7, 365 days a year. Other cloud providers might have a similar stack of capabilities, but the way that we deliver this platform is unique in many of these different approaches. So we've talked about the data center, the perimeter, the interior of the data center floor, the proprietary hardware that we're using to protect data, where these data centers are located. But what is also unique about our platform is how those data centers are connected. Google owns and operates infrastructure that connects our data centers to each other and nearly every ISP on the planet. Now, from a security perspective, this differentiates us from our competitors because unlike a traditional on-premise or even competing cloud solution, instead of having to move across a public intranet or have multiple hops from data center to data center, which are vectors of attack, Google uses its own proprietary network. So when a Google data center or a service is being provided from a global perspective like we do, it's traversing our own internal network. If you're a customer or you have a customer that is a particular concern about transport security, you can directly connect your application, even if that's on an in-device like an iPhone or an Android, directly to Google's network without going over the public internet. Again, another offer of high security. The next thing to consider when we start thinking about data protection and providing the service is updates and operating at scale. And this is without disruptions. So the way that we operate the Google Maps platform operates is that we don't have any scheduled downtime or service or maintenance windows. Our services are designed to be up and available as often as possible. Every service has outages. This also happens to the Google Maps platform, but these are all unplanned outages. And we reduce the likelihood of these outages by the way that we operate our infrastructure. We have the ability to roll out our solutions without causing an interruption or out having to bring them down for patching, for example. We're able to do live migration across different servers within our entire global fleet that allow us to stay up to date and, of course, roll out solutions in a managed manner. If there is a software vulnerability or there's a problem detected, we're also able to roll that change back. No one writes perfect software, so this is a constant requirement, and this is how our services differentiate from others. Now, let's pivot a little bit and talk about data protection. So, encryption is a common means of protecting data both at rest and in transit, but Google does this in a very different way. I think I already mentioned that all communications over the internet to Google Maps platform require a properly terminated TLS connection, so that's encryption in transit by default. But we also encrypt all data before it's written to any disk. And encryption is inherent in all of Google's storage systems. So this is all done by design at scale rather than a security feature that's added on afterwards. But even the way that we store the data is very different. Instead of just writing it to a drive and encrypting it at the drive level or at the file level, Our Google file system takes information that comes in from any of our services. This could be log information. This could be information that's part of providing the service. We take that information and then we break it into pieces or chunks. Each piece or chunk is then encrypted with its own data encryption key or a DEC. That data encryption key is then encrypted itself. We call this a wrapping key or a key encryption key. The encrypted chunks are then replicated across our infrastructure. So in that list of data centers you saw earlier, we're going to take that encrypted chunk of data and we're going to replicate it on multiple servers, on multiple drives, on multiple racks, and multiple data centers. And this again is for high availability. Those encrypted chunks, even for our personnel who have access to a data center floor, cannot access the data. All of it is encrypted. Whenever that data needs to be served, again, whether that's internally or to a customer, the Google file system goes out, it grabs all those chunks, it pulls it together, it de-encrypts and reassembles the information. So it repeats the entire process in reverse. As a result, when you think about it from an attacker's perspective, if an attacker was able to compromise a server or individual key or gain access to some physical storage, they would be unable to read the data, as they would need to identify all of the different chunks, retrieve the chunks, and then retrieve all the associated keys and the key encryption keys in order to access this data. This is done by default across all of our services for Google Maps platform. All of the data stored on the Google Maps platform is encrypted at rest by default. This is done by design. This is not something that is added on as an afterthought at a later date or as part of a software design release process. Next, let's talk about the component of data security I think is probably most important, and that is people. At Google, we have some of the world's leading cybersecurity experts. Google Maps platform operates across many verticals and geographies, so there are lots of different security requirements, and of course, a wide array of threats that we're exposed to at Google that many other customers aren't. To put it another way, we're under constant attack. And because we're under constant attack, we're able to actually observe what's happening and then better protect our entire system as an ancillary benefit. We have a lot of data that we can gather and then use to protect our information. We invest a lot in security at Google, but not just in Google. We collaborate with other industries, with verticals. We work with folks in open source communities. We work with security researchers. We offer a bug bounty program. And the idea here is that hackers or security researchers or white hats are motivated by many different things. Some it's money, some it's fame. Well, we have a bug bounty program. We financially reward security researchers who find problems with our services, which allows us to provide a more secure service. We also have a Hacker Hall of Fame. So if they're motivated by fame or they want to be well regarded in the industry, we provide that as well. Google Maps platform, all of our products are also supported by the Google Bug Bounty program. So if we were to sum up how Google Maps platform differentiates itself from competitors, we want to start saying that, hey, our platform is different because we have end-to-end provenance and attestation in terms of security. We have purpose-built chips on purpose-built servers, which has information that is on purpose-built storage, travels across a purpose-built network, and purpose-built data centers. This, because we are controlling every step of the operation from chip to chiller, from hardware to network, this greatly reduces the vendor in the middle risk common in other platforms, where they're using off-the-shelf hardware, networking components, et cetera, that these breaches are common in the industry today. These are the very large investments that Google is making to help keep data as secure as possible. All right, let's pivot on to privacy. When I'm talking to customers, I talk to them about security. They're like, okay, you seem to operate in a very secure manner, but I want to understand what data you're collecting, what that data is being used for, and then how long that data is being retained. We want to be very transparent on this process. So let's start talking about logging data. So the majority of the data that we're collecting on Google Maps platform relates to logging data. So the data that we're using, the data that we collect in logs that we're using, they're used for 5 specific purposes. So we use it for providing technical support to our customers. We use it for monitoring and alerting within our system. We use it for enhancing system security, forecasting and planning for system resources, if we have enough server or network bandwidth to provide our platforms. And probably most importantly, we use that data to improve our products and services. So whether that's a consumer using Google Maps on their iPhone or an enterprise that's using a Google Maps platform to deliver a solution, we're collecting information in the logs to improve our maps. This allows us to provide a better product to our customers. So that's the differentiation. This is what we use the data that we collect from our platform to do. We are not using this data for things like advertising, profiling, or gathering some sort of business intelligence. We use it for these five reasons and these 5 reasons alone. This log data, as you can imagine, is highly sensitive. So access to these logs is very, very restricted, and only authorized personnel with a legitimate business purpose can request access to these logs. Any access that's granted is audited and reviewed for security purposes. The use of all these logs, again, this is all in writing, so it's not taking our word for it. This is all in writing as part of our Google Maps Platform Terms of Service and covered by our Google privacy policy. Let's talk about what data could be contained in a log. So we've talked about how the log data can be used, but what data is being collected in the log itself. So the logs vary slightly by product because different products, of course, perform different functions. But generally, we can say that the data that we're collecting is going to be the IP address of the requester. So the requester could be coming from a phone. It could be coming from a server that is being provided by a customer. It's implementation specific. But whatever IP address is invoking our service, we're going to log the IP address. We're going to log the date and time that it was invoked, and we're going to log the request URL. Remember, Google Maps platform is an API SDK-based solutions platform. So you're going to be passing us an argument. We're going to be logging whatever information that you're sending us, and then we'll be processing it accordingly. We'll be also collecting the account identifier. That's the API key or client ID, and that's used for billing. And then any sort of like request headers. So things like, web browser or operating system. SDKs, they're going to be looking at the name of the application that's calling it, the play version, etc. Just standard logging information that's used to meet those use cases we spoke about earlier. When we think about we're only using the data to improve our products, provide security, etc., that data is actually not very useful for very long. So what we do for log retention is that we retain those logs, and then after 9 months, we go through and we do an anonymization. So this is we go through and we remove portions of the logged IP address, because typically after 9 months, this is when any billing questions might be done. If there's a problem or a technical issue, it's typically addressed in this amount of time. So we go through, we keep the logs for 9 months, then we go through and we anonymize part of the IP address. And after that, the only other log retention that we may happen to question is that we have some anonymized and aggregated usage statistics that are derived from logs that we, again, use to plan our services. And we may keep those indefinitely. The next question I tend to get is, which Google Maps platform products use cookies? This is a very straightforward answer. We only have 2 products that use cookies. Now, in case you're worried about having to, in your implementation, having to delete or cycle or manage cookies, you do not have to do this. The client-side cookies are automatically deleted after 18 months. We only have 2 products that use cookies. So that's the Navigation SDK and the Maps SDK. So at the time of filming, we only have 2 services that use cookies at all. The rest do not use them. Full stop. What is that cookie data being used for? So we have those 2 services that have the cookies. What's that data being used for? I think the most important point here is actually the second point. Cookies are not associated with a signed-in Google account. So unlike a cookie that could be used for advertising or tracking a user, it's not associated with a signed-in account. So we're not tagging that to a user. We're not tracking their activity. We're simply using these cookies to determine our number of 7-day active users. We're using it for abuse prevention and version management. Full stop. And again, all of our Google Maps platform products that use cookies are also subject to Google's privacy policy. It's treated all the same. So, security is a shared responsibility. Google is responsible for the components that we control, but you as a customer or a partner also need to help secure your data and operate in a secure manner. So the best practice that we have is that we recommend that you restrict your API keys. So in production environments, we want you to set both the application restrictions and API restrictions. This will help protect you from fraud, and it allows you to operate our platform in the most secure way possible. Data usage and privacy. So again, we've talked about what data is being used for. Let's make some very strong statements here. We talked about in logging, about log access, about how we guard against insider access. Only Googlers with specific business case needs, and this of course can apply to access logs. We guard against access, it's all monitored, it's reviewed, and it's audited. All data is encrypted at rest by default. And regarding access by, let's say, not Google, let's say governments or third parties, we never give governments or third parties any sort of backdoor or unrestricted access. All access needs to follow proper legal channels. Transitioning from privacy to compliance. So again, we have many customers that work with regulated data, and they want to understand what Google can do to help them meet their compliance requirements. So let's talk about the third-party audits and certifications that are held by the Google Maps platform. So firstly, as of last month, I'm happy to re-announce that the Google Maps platform has attained CSA Star Cloud Security Alliance Star Level 1 certification. More on that in a moment. Google Maps platform has ISO 22301 certification. This relates to business continuity management and disaster recovery. If you are running your business on our platform, you want to know that it's highly resilient and going to be highly available. Again, this is why we operate globally, and we've talked about that there, but this is certified via our ISO 22301 certification. If you're concerned about the environmental impact of using our services, we have ISO 50001. This is an international standard for energy management. This applies currently to all of our EU data centers with plans to roll it out globally in the near future. Talking a little bit more about encryption. So we talked about how Google operates and how we encrypt data at rest and in transit, but many organizations that have very restrictive security requirements want to know what encryption is being used. They want to understand what cipher suites are in play and have they been tested. So at Google, what we've done is we've taken our encryption module. It's actually called boring crypto because it's fairly boring. We've cut out a lot of the, I'd say, the ancillary unnecessary pieces. And what we've done is this validated encryption module is used in our production environment for data in transit and data at rest. And what we can say is that our encryption module, Boring Crypto, has FIPS 140-2 compliance, and this certification and the certificates of testing are available on our website. So that's where we are currently. Let's talk about the exciting year that we have in front of us for 2023. So by the end of the year, we're looking to have both ISO 27001, SOC 2 and 3 for all Google Maps platform services. So this is very exciting. We'll be having some services getting the certification as soon as Q2, with the remainder getting them in Q4. We're also planning on getting HIPAA compliance. HIPAA is a U.S. It's a U.S. law, federal law that governs the storage and processing of healthcare data. So we're looking for HIPAA compliance again by the end of the year. We're also planning to go for FedRAMP. So we're pursuing FedRAMP Moderate Impact Level 2. Again, we're looking at this for the majority of the Google Maps platform products, and we're aiming to have this by the end of the year. Last but not least, we're also aiming for CSA Star Level 2. I'm going to talk about CSA in depth here. So if you're unfamiliar, CSA, or the Cloud Security Alliance, is a nonprofit organization that's focused on helping customers evaluate cloud providers. So they have something called the CAKE and the CCM, the Cloud Controls Matrix. The CAKE is basically a questionnaire with 270 different controls on it, where a vendor, in this case Google, provides an answer to all of these different controls. Now, what you can do as a customer or a partner is you can then go out and you can review the answers from other providers, from an Amazon or a Microsoft, for example, to better evaluate which platform meets your needs. Now, Google is a trusted partner with the CSA. So we've been working with them for several years. So being a partner just means that we go to trainings. We have dedicated folks like myself who work within our organizations to kind of further the adoption of the platform. But the type of certification we have here is a level 1 certification. So for those 270 controls, I talked about the CAKE. That really stands for Consensus and Assessments Initiative Questionnaire. It's a bit of a mouthful. But we have answers to all those 270 questions. And this is a self-attestation. So this is what Google says it does to meet these controls. Now, that's a good place to start. But level 2, what we're aiming to get by the end of the year, is third-party audited verification of those 270 answers for CSA Star Level 2. So CSA Star Level 1 is Google saying what we do, and CSA Star Level 2 is independent assessment and verification that our answers are indeed accurate. Google Maps platform is not the first Google service to have attained CSA Star certifications. Google Cloud has levels 1 and 2. Google Workspace has levels 1 and 2. Google Maps platform, like I said, we just got level 1, and Looker has level 1. And finally, we are really looking forward to getting level 2 by the end of the year. If you would like to see or use all of our 270 different approved answers for security, privacy, and supporting regulatory requirements, it's available via the link below, or you could just Google it. Last but not least, we want to talk about compliance with legal frameworks. We've talked about third-party attestations and certifications. We now want to talk about legal compliance. So legal compliance, we want to talk about these legal frameworks. They operate roughly on both the national, or in this case, we're going to talk about U.S. states specifically. So national privacy laws that customers may need to meet requirements for in the European Union, it'd be something like the GDPR. Brazil, they have the LGPD. Switzerland has the Federal Data Protection Act. And the UK has the new version of the UK GDPR post-Brexit. All of the language regarding compliance with these legal frameworks are contained within our terms of service and our standard terms of service. So these are out there available to apply for all of our customers without any additional negotiation required. Now, if we were to pivot to just the United States for a moment here, we've had language for the last, last several years in our contracts related to the California Consumer Privacy Act, or the CCPA. In January 1st of this year, we had 4 new states pass privacy laws that, again, our customers may need to comply with. So we updated our terms of service with a U.S. state privacy law addendum, which contains language to help customers comply with laws in California, Virginia, Colorado, Utah, and Connecticut. With that, I want to thank you for your time and attention today. And we've talked about how Google protects data at rest, at transit, with physical controls. We've talked about data privacy, and we've talked about helping customers meet their requirements under legal and regulatory compliance. Thank you very much, and look forward to speaking with you in the future.